So this is the controller board for the laser. It's a small GRBL shield, and it basically have these two stepper motor controllers. There's also Arduino Pro Micro and a laser power regulator, weak laser, and a power button. Let's start with the stepper motor drivers. There's two of them, so one for the x-axis and one for the y-axis. One of them is running two motors at the same time. You can adjust the power of these drivers by screwing this little trim pot while measuring the resistance with a multimeter. Measure the voltage reference pin and ground. Based on the RepRap wiki page, Pololu drivers can output 1 amp trip voltage, so basically don't set it higher than 0.4 ohms. These steppers are very common in 3D printers, and there's two ways people usually do the calibration. One way is to set it by trial and error by moving the axis and trimming the settings so that it's not too low or too high. Another way is just to set it to the safest maximum, so either 0.4 ohms or a bit less. You can easily remove the stepper drivers and the microcontroller from the board if you need to replace them for any reason. Under the microcontroller you can find a jumper setting. Next to it you can see a text that says 8 or 9. Which is a reference to the GRBL version 0.8 or 0.9. Between these versions, the pinout changed, so if you upload the latest GRBL to your microcontroller and don't change this setting to pinout 9, your board won't work correctly, but also it will instantly turn on the laser when you power it on, and it's with full power, which is obviously something you don't want ever to happen. So when you're doing changes to your firmware, keep your safety glasses on when testing. Next to the laser power regulator, you have a jumper where you can choose if you want to use the laser with full 12 volts or through the regulator. My laser is configured for 12 volts, so I'm just going to use that. But for example, if you have a diode that needs 5 volts, you would break it by pushing the 12 volts directly there. So you can use the voltage regulator and set it to output 5 volts. And it works a bit similar than the stepper drivers, so you can control the voltage with the trim pot. I'm just going to use the full 12 volts and control the laser strength through the G code. This GRBL shield has a brand of eleks maker, and I did have some trouble of connecting all the cables to the board correctly. But I managed to find the same board by the name eleks GRBL Mini 1.6, which has a pin out for all the cables. The second y-axis connection is already reversed, so you can just connect the cables and it should be good. It's usually a good idea to remove the Arduino from the shield before uploading the firmware. So to upgrade the latest GRBL, just connect your USB cable to Arduino and then install the Arduino software on your computer. I'm running Linux, so I can just install it through the terminal. But if you're running Windows or OS X, go to the Arduino website and just download it on your computer. Next thing you want to do is to go to the GRBL site and then clone the repository or download it as a zip file. From the GRBL wiki, you can find instructions how to install the GRBL files to Arduino as a library. So you need to install it as a library in order to be able to upload it to the Arduino. So just follow the instructions suiting your operating system. So I wanted to install the GRBL through the Arduino because now I can edit the settings of the GRBL before I upload it to the microcontroller. So if you want to change any settings of your GRBL before you're uploading, you have to edit the config.h file in the GRBL folder. By default, the GRBL settings are okay for this board, so you can just try it without editing anything. Open your Arduino, and then from the sketchbook and libraries you should find the GRBL upload, and then just select the board to Arduino Pro or Pro Mini, 5 volts, 60 megahertz. Set your USB port to be correct, and then upload it to the microcontroller. If you have problems installing the GRBL as a library, you can find more information from the Arduino's website. They have listed all the directories where the libraries should be placed in order for them to work. To control the laser, I'm going to use Universal G-code sender. It works in every operating system. You can find it on the GitHub. They have a stable releases. I'm just gonna get the latest stable build and then run it. Now, when you get it open, you should first connect to your device. So select the correct USB port and then press open. And you should get a greeting from the GRBL. So I get the GRBL 0.9J version, and I can send comments there to set the GRBL settings and view the settings. So let's see the step settings, for example. So I can see here there's 3000 millimeters per minute for max rate of moving. So I'm gonna change these a bit to move a bit faster. You can find more information from the settings from the GRBL wiki page. So here you can see all the settings and what kind of comments you can send there. So I'm just looking how to change the settings. So here's an example how to save a GRBL setting. I'm just gonna copy this and then go back to the G-code sender, paste it here, and then change the first number to correct value, which is 110. Set this to 6000, press enter, and now it should be changed. And I'm gonna do the same for 111 and 112 as well. So now to use this, there's different tabs here. You can control the laser, send comments to it, but if you go to the file mode, you can find a browse button and then choose a G-code file from your computer. Just gonna load something I made previously. Press visualize to see how the G-code looks like, and then when you just press send, the laser starts to work. And now you can see the yellow rectangle, and that's where the laser head is currently moving. If you want to test the laser, you can type M3 command to turn the laser on, and the S after the M3 is the power level, so I just put it to 1, so it's the medium power. M5 will turn the laser off. I set the maximum power to be S256 from the GRBL settings, so that's the full power, and again M5 to turn it off. The default is set to 1000, so if you want to change it, then just go to the config.h file and change the value to something else. On top of the laser, there's a TTL button that acts as a weak laser button. So if you press it, you will get the weak laser. Now I didn't go through all the GRBL settings. For example, I had to invert the axis in order to get the motors run to correct direction. But if you need more details of something, just give me a message and I can make a video out of it. On the next video, I'm going through how to generate the G-code for the laser using some Inkscape plugins.